All right, welcome my little pre-calc babies to chapter 6, section 2, and now we are studying the law of cosines. So we have the law of sines, we have the law of cosines. Well, let's start with the obvious question. What is the law of cosines, right? And then when should I use it? Let's start with the when should I use it part. So you'll use the law of cosines when you have a triangle that's set up as side, angle, side, right? So side, angle, side. That would mean that you have two sides, and this time you have an included angle. All right, ready? So let's make up something. Let's just say that, I don't know, little b is 10, little c is 20, and angle A is 50 degrees. Right? So if I put everything in the right spot, little b is 10, little c is 20, and angle A is 50 degrees. Now, this is the type of triangle that the law of sines will not work. And I tell you what, ready for a secret? This is super informal, super sloppy. But let me. If I were explaining to my 9-year-old when should you use the law of cosines or when should you use the law of sines, here's something I would say. Ready? I would say to my son, do you notice how you have 3 different letters? You have a B, you have a C, you have an A, right? Now, in other words, you have a side B, a side C, and an angle A. Because you have no relationship between angle and side, right? You don't have little a and big A, or little b, big B. Because these are 3 different letters, you're going to have to use the law of cosine. Now, again, that is super, super sloppy, but just think about it. I mean, the law of sine says you have to have that proportions that are, and you don't have a relationship between angles and sides. So this is never going to work, and never going to work when using the law of sines. So we're going to have to use the law of cosines. The last scenario where you would have to use the law of cosine would be if you're just given 3 sides, right? If I give you no angles at all, like say 10, 20, 25, if I give you 3 sides, for sure you're going to need a law of cosines, right? So how do we use the law of cosines? And let me go ahead and see if I can bring in that law of cosine formulas. So this is one of those situations where you would just, unless your professor were to ask you to place these to memory, right, which would be, well, it would be an exercise in memory, but it would not be an exercise in learning mathematics, right? You shouldn't confuse the two. If you have access to these formulas, or a formula sheet, then what you're going to do is you're going to, and I can show you where this comes from. It's not, if you come see me, when we have office hours, if you come see me during the office hours, the proof of how to get to the law of cosines using distance formulas is fairly easy. But I'm not going to go into that right now. What I want to do is jump in and let's start using the law of cosines. Ready? So it says solve triangle ABC. If what? If A is 60 degrees, little b is 20, and little c is 30. Right? So you have 2 sides and an included angle. You're going to have to use the law of cosines. Or, as I said informally, you have three different letters, no, right, include an angle. Only you have two sides, one angle. That's the key part. But you have three different letters. You have no relationship, law of cosines. So when we start, we're going to just start with, so looking at some of the cosine formulas off to the left here. It doesn't matter. I mean, they all basically say the same thing. It just, depending on what information you're given in the problem, right? So for us, I'm going to use the first formula, right? Because my goal right now, right, what is it that I need? I need to know what side A is, and I need to know what side, let's see here. I need to know what angle B is. I need to know what angle C is. So I'm going to start off, I'm going to see if I can figure out what side A is. So that's why I'm choosing that first formula. Ready? So as of right now, let's see if I can, bear with me here. Let's see if I can plug everything in. Ready? Let's go. So A squared is going to be equal to B squared. So B in this case is 20 squared plus C, which is equal to 30 squared, minus 2 times 20 times 30 times cosine of angle A, which is 60 degrees. I'm sorry that's a little bit cluttered, but look, at this stage we grab our calculator, we let our calculator do all this heavy lifting. 20 squared plus 30 squared minus 2 times 20 times 30 times cosine of 60, and we end up getting A squared is equal to 700. But we don't want A squared, we want A. So A is equal to the square root of 700, which is roughly 26.5, right? So I'm going to put the approximation just so you know that it's okay to round on these sections. But the square root of 700, right? That's the principal square root. We don't need the plus or minus because we're dealing with lengths of sides, right? Which are by definition positive numbers. So now, here's the good news. You are almost always going to be able to use the law of cosines for the first part of the problem, and then you can start using the law of sines, right? Do you remember what I said, that you had three different letters, you had no relationship, you didn't have a big A or a big B or a big C or a little c. But now notice that you have first off, did you notice that I wrote 26.5 by C? You did. You noticed that a long time. Why didn't you say anything? How dare you? You should have spoke to me through let's try this one more time. You should have spoke to me through the internet. I don't know why you didn't. No, A is 26.5. So that should go there. Sorry. So now, what was I saying? So notice in the beginning, you didn't have a relationship. No, you didn't have between angles and sides. But now you know what little a is, and you know what big A is. You know angle A, side A. You actually, from here, you just go right back and use the law of sines to figure the rest of this out. That's the good news. Okay, so I'm gonna quickly go through this. So if I wanted to find angle B, I would have B over sine of B is equal to, now the only relationship that I have is little a and big A, so A over sine of A. And let's just put everything in the right spot. All right, so I have 20 over sine of angle B is equal to 26.5 over sine of 60 degrees. Okay, so we cross multiply, we divide. So now we have sine of angle B is equal to 20 times sine of 60 degrees divided by, let's see here, did I put everything in the right spot? 26, yeah, divided by 26.5. Okay. Whenever I go quick, I just mess up, so I'm trying to go quick without messing up. All right, so roughly, if you take 20 times sine of 60 degrees and divide it by, I would divide it by the square root of 700, right? But divided by 26.5, roughly you're going to get 0.6547. Do not write that as angle B. That's not an angle. That's sine of an angle, right? So you need sine inverse of 0.6547. And when you do, we get roughly 41 degrees. Okay, well, this has now become trivial. I mean, what's the last piece of information we need? Well, we need angle C. And do you have the other two angles? You do. So 180 minus 60 minus 41 tells me that angle C is equal to 79 degrees. Not bad, right? So almost always you're going to use the law of cosine once, and then you'll get to go back and use the law of sines. So let's look at a scenario where you're given three sides of a triangle, right? You're not given any angles. So C is 4, A is 6, and B is 9. All right. So notice these steps that I've written here. It says this is what you want to follow, these steps. That you want to use the law of cosine, right, to find the angle opposite the longest side. So B is the longest side. So we want to find the angle opposite of that, right? So we're going to need big A, big B, big C. But angle B is opposite of the largest side, B. So we're going to start there. All right, ready? So let's grab our law of cosine formulas. Since I'm going to try to find angle B, I'm just going to use this guy right here. Ready? And let's start plugging in information. So B squared, so this is going to be 9 squared is equal to 6 squared plus 4 squared minus 2 times A, which is 6, times C, which is 4, times cosine of B, which is what I want. Ready? So I'm just make sure I didn't make any silly mistakes. A squared plus C squared minus 2 times A times C times cosine of B. Okay, good. So right now you grab your calculator, you let it do some heavy lifting, and you want to solve for cosine of B. All right. So if you do some arithmetic here, we should get cosine B is equal to, let me double check, it should be equal to negative 29 over 48. Okay? Don't worry about the negative. It's okay. Remember, cosine of a negative angle is equal to cosine of that same positive angle. So now let's actually take cosine inverse of negative 29 over 48. And what do we get, roughly? 127 degrees. So B is equal to 127 degrees. And yes, I almost wrote it right here again. All right, so 127 degrees. At this stage, as I said before, now that you have a relationship between a side and a corresponding angle, you can go back and use the law of sines. And I'm not gonna go through the rest of this. I'm just gonna go ahead and tell you that angle A is roughly 32 degrees and angle C is roughly 21 degrees. You would use the law of sines to figure out the second angle, and then use the 180 degrees sum of a triangle to angles of a triangle to figure out the third angle. Okay, so let me ask you just a quick question. So what would the law of cosines look like for a right triangle? Right, so just more advanced question. Not really advanced, but it's an aside. Tell me. So in other words, if you have a right triangle, and let's say, the angle that you're given is 90 degrees. And so if you plug in 90 degrees here, what would the law of cosine look like? Well, what is cosine of 90 degrees? Right, what is cosine? Well, cosine of 90 degrees is 0. So that would mean that you have negative 2 times A times B times 0. Right? Do you with me that all of this would zero out? And what would you be left with? You'll be left with C squared is equal to A squared plus B squared. Ta-da! Right? You'd be left with the Pythagorean theorem, which makes perfect sense. The Pythagorean theorem works for right triangles. If the angle that you're given is 90 degrees, the law of cosine is basically just the Pythagorean theorem. All right. So last problem for this section. So you know me, I like to either see the geometry or I want to see a word problem, right? Because I want to know when I would use it, or I want to see it being used. So let me read. So we have 2 airplanes that leave an airport at the same time on different runways. Okay. So I don't like to read the problem in its entirety. I like to stop at periods and make sure I understand. So if I have 2 airplanes and they both leave at the same time on different runways. So we can think of it as both airplanes originated here at the origin, but they're going, during takeoff, they're going different directions, different runways, because they're going different directions. All right, now one of these airplanes flies on a bearing of north 66 degrees west at 325 miles per hour. So as of right now, I want to make sure that we understand what this means. So let's write. So I'm collecting information, right? So plane 1 is on a bearing of north 66 degrees west. And we actually know it's moving at 325 miles per hour. So let me see if I can draw plane 1. Ready? I'll use green, right? So let's draw plane 1. So if I'm going north 66 degrees west, right? So the way you read bearings is, so if I was heading due north, then I would be, I would just be heading north. But I'm actually going northwest, but on a bearing north 66 degrees west. So the way this works is I want to rotate 66 degrees. Ready? There it is. There's my current trajectory, let's say. So I'm going to rotate 66 degrees in the west direction from north. Okay. Now I'm going to talk about that 325 miles per hour in just a second, but right now let me go ahead and figure out what we know about the second plane. So the other airplane flies on a bearing of south 26 degrees west at a rate of 300 miles per hour. All right, so plane 2. It's going on a bearing of south 26 degrees west and at 300 miles per hour. All right, so let's use blue to draw the second plane. So, okay, if it was heading due south, right, it would be going, if it was only heading due south, it would be going in this direction, but we're actually south 26 degrees in the west direction. So we're going to rotate 26 degrees. And now let me go ahead and draw that vector. Let me draw that trajectory. All right. So let me kind of clean this up a little bit. All right, so now let's go back and talk a little bit about the velocity here, right? It says, the question reads, last sentence, the question reads, how far apart will the airplanes be after 2 hours? Okay, so if we assume that plane 1 is moving at 325 miles per hour for 2 hours, right? Then we can do some quick arithmetic to find out that 325 miles every hour, 2 hours goes by. This plane is traveled 650 miles. Now, if you're asking me how did the people get up in, like if you're asking me the physics of how this is working, how did these individuals in this plane just instantaneously start traveling at 325 miles per hour without everyone on the plane either suffering from massive whiplash or dying? I don't know. So somehow they just started off at 300, maybe 25 miles per hour, just instantly. But likewise, if the other plane is also going at 300 miles per hour for 2 hours, that would mean that they have traveled 600 miles. So what I'm going to do is I'm going to go ahead and label. So plane 1, I know the length of this is 650. And plane 2, I know the length of this arrow we're going to say is 600. Okay? So 650. Sorry. I know this is Doesn't matter to you probably which color I use, but it does to me. Right, because I have to entertain myself while I'm talking to you, because there's no one else, just me. I don't have anyone else to talk with. Why? So let me continue. All right, so the question was, how far apart are the two planes, right? I mean, in other words, this is it. This is what you're looking for. How far apart are the two planes? So you can see that we have formed a triangle. Maybe it's better without so much clutter. Let me just draw the triangle that's been formed. And we know that, let's say this side of the triangle is 600 and this side of the triangle is 650. But do you agree with me? We don't know anything else about the triangle, right? For example, we don't know what this angle is yet. But can you think about how you would find that angle? Right? Can you think about how you would find the angle here? Well, hopefully you can. I mean, I'm just going to label this. Let's say this is angle B. Doesn't matter. Well, clearly angle B is going to be equal to 180 degrees. That's the straight line. Minus what? Well, minus 66 degrees minus 26 degrees. So angle B is equal to 88 degrees. All right, so now I know a little bit more about my triangle. This is 88 degrees. So, all right, so what's the question? Is the question to solve the triangle? No. Right? I mean, this is just, imagine this is the end of the movie, the love movie, where the two couples who have spent a wonderful summer together are at that airport, and emotions are high, and they have to get on separate planes, and they have to head in separate directions, right? These two lovers, and they're just somebody wants to know how far apart they are. 2 hours has gone by. It's been a lifetime since they've seen each other, it feels like, and I just want to know how far apart we are after 2 hours. Well, that's okay, because that's good, because the law of cosines is here to help you figure out the answer to this question. So what do you have? You have two sides and an included angle. And you're with me that we really only care about in this, we don't have to solve the whole triangle. We only care about what is the length of side B. That's how far apart you are. All right, well, let's finish this up. Let's wrap it up. So if I take my law of cosine formula, and since I've labeled it B, no, what happened there? Let's go ahead and start plugging in some information. Ready? Let's do it. So I have B squared is equal to A squared. And now I have to label things. I mean, I guess, let's see if you're with it. I'll just label this A. And I will label this side over here C. Okay? So that would mean that C is equal to 600. And that would mean that little a is equal to 650. Okay? So now let's go in and plug everything in. So this would be 650 squared plus 600 squared minus 2 times 650 times 600 times cosine of the angle between the two lovers, which is 88 degrees. All right, so we grab our calculator, we let it do this heavy lifting. B squared is equal to 755,278. That would mean that B is equal to the square root of 755,278, which is roughly 869 miles apart. Okay. Now I assume if it were true love, they would this individual would also want to know the angle that C makes and the angle A makes, so that they could find out the angle between them and their lover. But never mind, we're just going to run with the distance between the two people. The two individuals are 869 miles apart from each other. All right. So last piece of information that we need for this section. I think this is easy. You're going to like this. So this is this little formula. This is a very old formula. Okay, this is Heron's formula, and so I couldn't tell you a lot about this mathematician of antiquity. The things that I do know, I mean, this is pre-Socratic. This is, but Heron was from the little bit that I can remember off the top of my head was an engineer, and he had an engineer's approach to mathematics, right? So in other words, he was willing to accept some error in his calculations, right? And in this little formula, it says that, look, if I give you 3 sides of a triangle and you want to find the area of that triangle, then this little formula works beautifully. Right? So in other words, if I give you 3 sides of a triangle, that's all I give you, it's just 3 sides. And from those 3 sides, you actually want to be able to find the area of that triangle. Heron's formula works beautifully. Let me describe it to you in just a second. I tell you what we'll do is we'll make this easy, right? The Heron's formula works whether it's a right triangle or a non-right triangle, but I don't know. Let's just assume that this is a football field. Right, and let's see here. So we'll deal with, instead of yards, we'll just do feet. So if I recall, I think that the width of a football field is about 160 feet. And then we'll count the end zones as well. I think the width of a football field, the length of a football field, in counting the end zones, would be 360 feet. Okay, so sorry if that's a little bit. Just think of it as, in case that picture is a little bit sloppy, you want to know the area of just a half of that football field, right? So if you kind of run that diagonal from one corner to the other corner of the field, this is the triangle that you have. Okay, and I chose this because it's a right triangle, and the reason why I chose a right triangle is because we didn't need Heron's formula for the area of a right triangle at all, right? For example, the area of a rectangle is length times width. So if you just cut that in half, which is what we did, then the area of that right triangle is just half times, well, I can say half times length times width, or half times base times height is normally the way it's written. So let's go ahead right now using not using Heron's formula. If you grabbed your calculator and you wanted to find the area, right, maybe you had to seed this guy, you wanted to find the area of that right triangle, it would be 1/2 times 360 times 160, the area is equal to 28,000 square feet. Now that is the exact area. So what if we want, just for comparison, so we know what the exact area is, but what if we want to use Heron's formula, right? So if I know two of the sides, I can always use the Pythagorean relationship to figure out that the third side, in this case the hypotenuse, would be 394 feet. Okay, so let's remember I said that Heron was willing to accept some error, and in his mind it was just, hey, this is a practical way of figuring out the area of a triangle when all you know is the three sides. So how does this formula work? Well, notice that, my apologies if this is not clear, this is S times S minus A times S minus B times S minus C, right? So it's the square root of that. But what is S? So S is half the perimeter, right? So if you add up these three sides and cut it in half, you would have half the perimeter. So let's go ahead and do that right now. So S is going to be equal to 1/2 of 394 plus 160 plus 360. So S is going to be equal to half of 914, which is 457 feet, right? That's the perimeter. So you should listen to me. If you're thinking engineering, you're thinking sciences, put this formula in your pocket, right? Everyone else is using all types of trigonometry to find the area of a triangle when they have three sides, and you are using a 2,500-year-old formula. It's amazing, actually, how accurate it is. So, ready? So it does not matter what we call A or B or C. So we'll just say A. In this case, we'll say that A is, 360. The B is 160. And the C is 394. All right, are you with me on what's about to happen? So we're going to just we have all the information to plug into this Heron's formula. So it's going to be, so the area is going to be approximately equal to, let's do it, 457 times S minus A. So that's 457. Now I'm just going to go ahead and write, I don't know which one I called A, B, and C when I actually did the math for this problem, but it won't matter. So S minus B, S minus C, you should get 63, 297, and 97, right? So again, I don't know, it might be a little bit out of order because when I did it, I may have called A or B or C something different, but that's okay. We're here at this stage. So we grab our calculator. The square root of 457 times 63 times 297 times 97 is, I have no idea. Believe it or not. I think I'd normally ask the class to do it. So guess what you get to do? You have to entertain yourself for a second while I grab a calculator, because although I've been doing math a long time, I'm not smart enough to do that in my head. So let's see here. So we have 457 times 63 times 297 times 97. All right. So that's the square root of 829,439,919. Entertain yourself. Relax. Just entertain yourself for a second. So, assuming that I wrote that down correctly, 829,439,919. 919. So I'm getting 28,799. And let me make sure I did my math correctly. 360 times 160 times 0.5. Oh, I see. Maybe you saw it earlier. That should be 28,800, shouldn't it? When I did my math. This is what happens. This is what happens, man. That's when you do math in your head. 28,800 square feet compared to 28,799 square feet. All right. So, pretty darn good. Pretty darn good approximation. Now, your professor's not pretty good for that little math error, but that doesn't matter. So, it'll all be okay. And let's conclude. So, I will see you soon.